Such a polarization is called electronic polarization. Your gate is the boundary. So when you are in the house, your thinking is different. The moment you come out of the house, your direction of thinking changes. Because eyes are easily, because of the eyes, you are easily distracted. By looking at the environment, your angle of thinking gets changed. So like that, when electric flux line passes through a boundary, its direction gets changed. So you will study that normal components of flux densities are equal and tangential components of electric field intensities are equal. So the next unit is on magnetics. If current direction is given, I can give the magnetic field direction by using right hand thumb rule. So current direction is given. Let me keep my thumb in the direction of current. How I am folding my fingers, that gives the direction of magnetic field. If I take a screw and then rotate the screw in the direction of magnetic field, the screw will progress in upward direction. The right hand side is called Maxwell's first rule. Maxwell says, you tell me the direction of magnetic field, I will tell you the direction of current. So in the direction of magnetic field, you rotate a screw. How the screw is progressing, that gives the direction of current. So I am rotating the screw like this. Screw is progressing in upward direction. That gives the direction of current. So in the textbook you find cross and dot. So cross means into the board, dot means coming out of the. So you have arrow. On the back side of the arrow you have a cross. On the front side you have a sharp dot. So if arrow is coming towards you, you see a dot. If I release the arrow from here, if that arrow is coming towards you, you see a dot. Imagine a arrow is going this side, you will see a cross. So watch Mahabharata. So if you watch Mahabharata in Z daily, you find a lot of cross and dot. So cross means into the board, dot means coming out of the board. So we have to define magnetic dipole. Electric dipole means two charges separated by small distance. Magnetic dipole means two poles separated by small distance. So if I take a small current loop acts as an electromagnet that has a north pole and a south pole. So from south pole to north pole, if I show it as a small magnet, that arrangement is magnetic dipole, and magnetic dipole moment is defined as the product of current and area of that loop. You take the electron that is revolving in an orbit inside the magnetic material. Electrons are revolving in the orbit. So one orbit can be treated as one current loop, one circular loop. That one circular loop in which the electron is revolving is called one magnetic dipole. So magnetization or magnetic polarization is magnetic dipole moment by volume. Here the unit is ampere meter square, current in amperes, area in meter square. So before magnetic field is applied, the magnetic dipoles are randomly oriented. When magnetic field is applied, all the dipoles are regularly oriented. This is exactly similar to your classroom. Before the teacher enters into the class, you are randomly oriented. Net output is 0. The moment the teacher enters, you all will be aligned towards the teacher. There is some net discussion. So initially the magnetic dipoles are randomly oriented. Magnetization is 0. But when you apply a magnetic field, all will be oriented in some direction. Net dipole moment is there. Similarly, magnetization is there. So if you are applying current to an before you apply current to an electromagnet, Inside that electromagnet, the dipoles will be like this. Once you apply current, the dipoles will be oriented in one particular direction. This process is called magnetization. Magnetization means bringing the molecules from random orientation to regular orientation. Second law, first law is Gauss law, second law Biot-Savart's law. So Biot and Savart, two French scientists, together they want to trouble you by adding mathematics. Maxwell is the biggest person who is troubling you. So if Maxwell comes and stands here, you will shoot Maxwell because he has added vectors to the basic class. So this is a current element. A section of current carrying conductor is current element. From the current element at a distance r meter, there is a point P. I want magnetic field intensity. Biot and Savart says magnetic field intensity is directly proportional to the source, that is current element. Inversely proportional to square of the distance, directly proportional to sine of the angle. If you combine all this, it is some constant 1 by 4 pi ideal sine theta. Later on you will write it as ideal cross AR divided by R. It is in cross product form. AB sine theta form, you will write it as A cross B, that divided by R. So whatever Biot and Savart have told, same thing Ampere has told. Ampere filed a patent in a different place. Biot, Savart, they have also given their invention and both are recorded. So you will be studying Biot, Savart's law as well as Ampere's law, but both are conveying the same thing. Magnetic field will be very high nearer to the conductor. As you go away and away, the magnetic field intensity will be decreasing. The best example is that incandescent lamp. Near the incandescent lamp, light intensity is very high. As you go away and away, the light intensity will be decreasing. Second Maxwell's equation. I said proof of 4 Maxwell's equations I am giving. So this is the proof for second Maxwell's equation, the simplest proof. This is a very simple experiment that you can do it. Take a straight conductor, keep a paper, then throw iron dust. If you take a straight conductor, have a paper and throw iron dust, the iron dust will take the shape of concentric circles. Which you can do it. Take a straight conductor, keep a paper and then throw iron dust. The iron dust will take the shape of concentric circle. Therefore, magnetic field due to a straight conductor is in the form of concentric circles. You cannot see magnetic field, but you can see the effect of magnetic field by doing this experiment. If it is electrostatics, you have to throw mica dust. Take a capacitor, between two parallel plate capacitor you throw mica dust. Then the dust will take the shape of horizontal lines. Therefore, the electric field due to a parallel plate capacitor is in the form of straight lines. So now if I take a volume delta V is a very small volume, the flux entering and flux leaving are equal. So if flux entering and flux leaving are equal, net flux is 0. Divide by delta V on both sides, 0 by delta V is 0. Net outflow of flux by volume is div V. So div V equal to 0. This is second Maxwell's equation. This is also called field form of Biot-Savart's law. What is the meaning of this equation? What is the meaning of div V equal to rho in first chapter? What is the meaning of this equation? Div V equal to 0. The meaning of div V equal to rho, there is a separate positive charge, there is a separate negative charge. From the positive charge, continuously flux is coming out and it is terminating at the negative charge. So in electrostatics, there is something called positive charge, there is something called negative charge. So can I say similarly in magnetics, there is a north pole, there is a south pole, isolated north pole and isolated south pole, then flux starts from north pole and terminates at the south pole. Is that correct? Is that statement correct? Can I say there is an isolated north pole, there is an isolated south pole and magnetic flux starts from the north pole and terminates at the south pole? If that statement is correct, I should get div V is equal to something finite. I am getting 0. Sources are there in electrostatics, but in magnetics there is nothing like a source and sink. There is nothing like an isolated north pole and isolated. If I take a permanent magnet and break it into two pieces, each piece will behave as a smaller magnet. So you cannot have a separate north pole, you cannot have a separate south. So from this equation, Maxwell explained that isolated magnetic poles do not exist in the real time. Isolated charges do exist, but isolated poles do not exist. That is the meaning of this equation. Lorentz law. Whenever a charge is kept in the electric field, it experiences a force. This happens in CRO. Inside the CRO, two plates are there, you have electric field. When a charge is kept, it experiences a force. It goes and hits the screen, you find a spot. Or when you enter into the theater, there is a field, Surya field or Rajni field. You are the charge, you start dancing. So when you enter into the theater, you experience a force. So when a charge is kept in the magnetic field, also it experiences a force. Suppose if both magnetic field and electric field are there, by superposition principle, total force is sum of the two forces. So this equation is called Lorentz equation. Ampere's law, basic Ampere's law. Ampere's law says work done equal to MMF. MMF is N into I. We will take the example of temple. The temples in South India. So the temples in South India, Hanuman is there. You will make one round around Hanuman. Around Ganeshan you will make 3 rounds. So you do more work. So Ganeshan will give you more benefit. Around Navagrahas you make 9 rounds. So work done around Navagrahas is 9I. Work done around Ganeshan is 3I. In general, if there are n number of gods, then the work done would be n into I. So work done is MMF, MMF is n into I. In field theory, we always take n equal to 1. In field theory, we always deal with one single conductor, we don't deal with n number of conductors. So if n is equal to 1, then work done is equal to current, where I is called conduction current. Conduction current is the current due to free electrons. Free electrons are like you are very free, you can go anywhere. Like that, the electrons inside the conductor are freely moving. Current due to free electrons is called conduction. So work done is equal to conduction current. So there in electrostatics you have studied electrostatic boundary conditions. In magnetics you will study magnetic boundary conditions. Example, iron air boundary. Iron air boundary. Surface of transformer. Transformer core is made of iron. Above the transformer, air is there. So if you take the surface of the transformer is iron air boundary. So flux starts from iron. When it comes to air, its angle changes. Like your angle of thinking is changing the moment you come out of the house. So whatever you have seen in electrostatic, similar things happen, similar equations you get. So there is a lot of similarity between electrostatics and magnetics. Once you finish electrostatics, magnetics become easy because the equations are similar. So tell me, what is Faraday's law and what is Lenz's law? What is Faraday's law? First we will see Faraday's law, then we will see Lenz's law. Very popular lab viva question, what is Faraday's law? You start with a very wrong answer. Whenever a current carrying conductor cuts flux. That is the statement which you always give. Already if current is there, why should I go to Faraday? There is no current. When a conductor cuts the flux, then EMF is induced. So I have a conductor and I have the flux here. So when the flux linked by the conductor is changing and EMF is induced, and if the circuit is closed, there will be a current. What Oersted says, can you tell me what is the statement of Oersted? Oersted has brought a magnetic needle nearer to a current carrying conductor. So when a magnetic needle is brought nearer to a current carrying conductor, it gets, when a magnetic needle is brought nearer to a current carrying conductor, it gets deflected. Then he said, near the current carrying conductor there is a magnetic field. Oersted says current can produce magnetic field. If current can produce magnetic field, why not magnetic field produce current? Look at the thinking of Faraday. The greatness of Faraday, out of all the findings, the greatest finding is Faraday's finding. Without Faraday, no light, no fan today. We are enjoying the light and fan and AC because of fan. If not Faraday, one of you would have invented that. But Faraday has invented already. So, if current can produce magnetic field, why not magnetic field produce current? And his thinking is right. So this magnetic field has produced a current in this loop. So EMF is proportional to rate of change of flux. Magnitude of EMF is proportional to rate of change of flux. And this induced EMF opposes the cause of the creation. In a generator, you are applying a force and a force is induced. The induced force opposes the applied force. In a generator, I have to drive the coil. I have to rotate the coil. I am applying a force. And a force is induced in the rotor. That force opposes the applied force. That is what is called Lenz's law. Lenz's law says son will fight with father, or daughter will fight with mother for property immediately. Effect opposes the cause. Son fights with father. Induced force opposes the applied force. To represent that effect, I am adding a minus sign. This minus sign is given by Lenz, and d psi by dt is given by Faraday. This equation is a combination of Faraday's law and Lenz. Faraday says magnitude of EMF is proportional